share today how you can get your data AI ready with Unstructured and DataStax. And today we're joined by Maria Kalusova from Unstructured, staff developer advocate, and Eric Hare, my colleague at DataStax. Welcome.
Thank you.
Great. Well, it's great to see y'all. We were just talking before the show began, and let's maybe start really high level with some introductions, and then I want to dive straight into what it even means for data to be AI ready. So maybe we can start with Maria. Can you tell us a little bit about yourself, the Unstructured, and the work that you're doing there?
Absolutely. My name is Maria Halusova, and I'm a staff developer advocate at Unstructured. At Unstructured, we fuss over data. So unstructured data specifically, we pre-process data for all kinds of AI applications, mostly RAG applications. And there are a lot of challenges associated with that, and we help solve those challenges.
Fantastic. And I can't wait to dive into what that means in a little bit more detail. But before that, of course, Eric, would you give us a short introduction to yourself and the work we're doing at DataStax?
Yeah, hi everyone, really excited to be here. So I'm a software engineer at DataStax, and one of the primary focuses that I've had is on building integrations between AstraDB, our database offering, and platforms like Unstructured. So making it really easy basically to leverage Unstructured when you're building RAG applications that target a vector database like Astra.
Fantastic. Thanks. I'm so excited to dive into all of this. Now, one unifying thing that both of you mentioned was RAG applications. And when I mentioned AI readiness, Maria, you said Unstructured helps with this, particularly also with building RAG applications because there's some complexity there. When we talk about RAG at events, I just got back from a conference yesterday, and we did this thing from the stage where we asked the attendees, how many of you have heard of RAG? In an audience of 3,000, 2 hands went up. And so I think it's very important that we actually take a few minutes, maybe not too many, but just define RAG for the listeners here, and then we can dive into specifically Unstructured's role there. Maria, would you help us just by explaining RAG in detail?
Of course. So RAG stands for Retrieval Augmented Generation, and it sounds complex and sounds very sciencey, but it's really a very simple idea that you give some context to your LLM. So LLM does the generative part, it generates text, and the issue with the off-the-shelf LLMs is that they have been trained on massive amounts of data from the internet, but they have never seen your personal data or your company's data about your internal policies or customers or any kind of proprietary data. They have never been exposed to that kind of data, and they're also limited in time because they have a knowledge cutoff date. So past certain date, they don't know about any of the events that happened after that. And RAG is a way to give additional context to an LLM to help supplement some information and to help the LLM to generate a useful response to whatever user query can be.
Fantastic. Thank you for that. Yeah, that's so helpful for the vast majority of people, because even here in the comments, Kevin mentions, he says, RAG, that's what I use to clean my kitchen counter. Indeed, we're not talking about a cloth here. We're talking about a technique to bring real-time context into large language models. And also, correct me if I'm wrong here, but the right context, right? Because like a number of folks have reported with Google's AI overview feature, they ask questions, for example, how many rocks should one eat per day? And the answer is hallucinated with 3 or 4 or something like this. But that's because the training data often includes like jokes. And so the right answer isn't often given because of this. And RAG can help with that. Eric, is that accurate at all?
Yeah, absolutely. It becomes kind of the case that RAG is a way of like augmenting the information that is out there with the information that sometimes you need to pull in from sources that might not be indexed in LLMs by default for various reasons, proprietary, brand new information. And so combining those two concepts, you can really like build something pretty cool with it.
Excellent. I'm excited to find out what exactly we're going to do. I understand we have some demos and some really great things to share with the attendees here. Before we get into it, I want to be very clear that this is very much not just a trial log, as you may be watching on the live stream, but for those leaving comments, we read all of them, and we're more than happy to take your questions if and when you have any. With that, Maria, let's dive into unstructured. You mentioned unstructured helps with AI readiness, specifically with RAG applications. What is unstructured and how does it do that?
I have a short answer and a long answer to that. So the short answer is that Unstructured is a startup that has built tools to make the most frustrating step of building RAG applications easier. And that step is pre-processing unstructured data and making it RAG ready. And the longer answer is, for the longer answer, it's important to understand that you really do need to have good data to have a useful RAG applications, because data fuels AI, data fuels RAG applications, or even fine-tuning use cases. And the most abundant type of data in any organization, any company, any business is unstructured. Up to 80% of data created on daily basis is unstructured. So these are PDFs, Word documents, PowerPoint presentations, Markdown, HTML, so on and so forth. So if you think about contract, policies, legal document, marketing documents, field reports, and so on and so forth, all of these are stored in unstructured formats. They encapsulate a lot of important information about the business itself, the customers, the products, the kind of insights that are often not available in structured data. And so that's why you often want to leverage those documents, but it's not easy to use them because they're not very usable in their raw format. So you have to pre-process them first. And that is complex because you have to first aggregate them from a whole bunch of different silos that they are scattered across. You have to figure out how to parse all these different native formats. In certain cases, like with PDFs, images, PowerPoints, you will have to figure out how to use possibly OCR models or document understanding models or VLMs to extract content from those documents. And then, of course, you need to understand how you want your data model to look like. So this is uniform across different sources, different native formats. And then, of course, you need to figure out where you're going to store them, how you're going to upload to your destination. And so this is what unstructured takes care of, all the steps from the ingestion up to uploading the RAG-ready results into a vector store. So we don't orchestrate RAG, or we don't prescribe what LLM you should be using. Unstructured focuses on one thing only, is making your raw unstructured data usable and ready for whatever RAG application you want to build.
Fantastic. Thank you so much. So if we understand that together, and by we, I mean all the people in the comment section as well, unstructured can help get data become RAG ready by essentially converting it from whatever format the data is originally in into an alternate format. And this alternate format can then be used for RAG workflows. Is this alternate format text? Because like if we consider RAG, right, RAG is dependent on prompt engineering, meaning you get context, you inject it into your prompt, and then you ask your question. Is the final destination of unstructured's processing text? Or is there some intermediary layer that then an application would take forward for a RAG use case?
So you're correct that when you pass a document to an LLM as context, you pass text. However, when we process unstructured documents, we return JSON because we want to add metadata to that text as well. Documents don't exist in vacuum. they can refer to, they can describe different products. They can, there are different file types, different sources, different languages, and you want to have as much metadata as possible with your results, so that you can apply maybe metadata pre-filtering, or maybe you want to curate your data and drop some parts of it before you use it. So for that reason, it's not just the text that we extract, but we also try to get as much metadata as we possibly can from all of those documents. And so that results in a JSON document that we then load into a vector store.
Incredible. Okay, so one could perhaps argue that unstructured's processing step helps take data from unstructured formats and prepare them to even be structured. Because if you're getting JSON, you can then group certain JSON properties together, form even model relationships with them, perhaps build a knowledge graph, and store that somewhere as well. Is that close to something possible?
Yeah, you can absolutely do that. Yeah.
Awesome. That's so great. Okay, so now we start to understand why the partnership between DataStax and Unstructured is so synergistic, because Unstructured is the pre-processing step where the next obvious destination is a vector store, where you store the unstructured data that you can then use for similarity search. We have some questions in the comments, but since we're following the pipeline for RAG applications all the way from the unstructured beginning, let's talk a little bit about the sink, or the destination of that processed data, which is the vector store. Eric, would you be willing to expand there? Eric, you're muted.
Sorry about that. Yeah, definitely willing to. So basically, Unstructured has this incredibly powerful framework of what they call destination connectors. They actually have source connectors too. And Maria, if I say anything incorrect here, just interrupt me. But basically, the power of the vector store component is that we already built this destination connector that supports Astra. And what that means is essentially there's one really simple script to define your pipeline, which essentially that pipeline is going from your unstructured document, which, as Maria talked about, could be all kinds of formats, PowerPoints, etc., and going through all the stages needing to make it AI ready and RAG ready, and then immediately getting back a collection in Astra DB where the text from that document and other components of that document have their vectors automatically computed. So you can essentially start querying and doing similarity search, with really minimal effort. It's mostly just getting API keys in order, and it's pretty powerful what they've built.
That's incredible. And so Astra DB, being this destination connector, would then take that forward and be used to build a RAG flow. How exactly would a developer then take the output of Unstructured and build a RAG application?
Yeah, so there's a lot of options here, and there's some that might be more low code and some that are more for the seasoned developer. But one option is, if you're either familiar or willing to get your feet wet with some of the more common frameworks for LLMs and AI, LangChain, Llama Index, etc. Basically, once you've done the step of storing your unstructured data into your Astra DB vector store, it's again almost like a one-line connect to your Astra DB collection and start doing similarity searches and start building your RAG pipeline. So you can imagine pretty much the whole suite of functionality that's in LangChain, for example, is now at your fingertips. And you began simply from a PowerPoint or from a collection of PowerPoints in order to start building that.
Fantastic. I can't wait to see all of this in practice. I think we have some stuff prepared for that. One question before we go further from the demo is for Maria. Somebody asked here in the audience, Jimmy Burns is asking if PDF and spreadsheets are also transformed into these. He mentioned text in the comments, but we already established it's a JSON. Is that accurate? So Unstructured can take PDFs, spreadsheets, and other formats and transform them into something RAG ready.
Yeah, so the way we do it, we support 25 plus different file types. That includes PDFs and Excel and HTML, Markdown, many more. what we do is we take the document in, and then we partition it and we split it into individual document elements. We call them document elements. So document elements, this can be a title, a paragraph, which we call narrative text. It can be a table, an image, a list item, footer, header, all those different categories of logical elements of a document. And this is helpful when we further transform those documents and chunk them and embed them. It is specifically helpful for chunking because we understand this way the document structure, and we chunk in a smart way so that the content of different topics are not mixed within the same chunk, which helps further down the stream with the retrieval process, because you want to retrieve the most relevant information. You don't want to retrieve a chunk that partially contains something about topic A and partially contains information about the topic B. So that is one of the reasons why we split those documents. So the JSON that you receive contains these document elements, and every element contains text, category or type, and additional metadata. And if you do the embedding step as well, then that document element will also have embedding there. I hope this answers the question.
That definitely does. Out of curiosity, and this is maybe a little bit silly, but you mentioned so many different file types. What's the most unexpected one? For example, can unstructured process like a movie and give you a big JSON array of each line from the movie or something like that?
Not yet, but
Okay.
Maybe soon.
Fantastic.
But I guess
we have more questions.
If you're asking
Sorry,
about unexpected files, I think one of them can be an email. We can process emails as well. And then, for example, for emails, in the metadata, you can have the recipients, the senders, this kind of information. Attachments to the email can be processed as well. So I guess this could be more of an unusual type.
Fantastic. That actually gives me already some ideas I can use to build vector search for my email client. Case. There's so many questions. Hey, listen, I want to take a moment and really appreciate the audience here, because often live streams, you never know how they're going to go. Sometimes a lot of people want to interact, and other times it's just us. But since the audience is being so engaged, I'd love to actually pay more attention to the audience and just answer their questions. I understand we do have some demos prepared, but if we can prioritize the audience here, I think it would be a better service to them. And then we can handle these in follow-up discussions. So with that, there's a question from Sofia Caterino asking the security measures and how we can avoid, for example, taking like confidential documents, passing them through unstructured's processing, and then feeding them to an LLM, where the LLM can then steal that data or otherwise use it to train itself, or have the vendors of the LLMs reuse them in the fine-tuning processes. I think, and maybe a question to extrapolate from this is, does unstructured in its processing pipeline offer ways to strip or redact certain data from formats that go through its processing? So
there are several aspects to this question. First, the security. Unstructured is SOC 2 compliant and it's HIPAA compliant. You can process your documents with unstructured hosted API, but we also offer unstructured on Azure and AWS Marketplace, so that you can have it in your own VPC infrastructure so that the data stays there and never goes anywhere. That's one of the questions. As for stripping certain parts of content, you can set up your pipeline to first maybe partition the documents, and once you have the document elements, you can curate the results. So you can go through those JSON documents however you want, remove information that you don't want to be used for your application, and then you can use another pipeline to do the rest of the steps, for example, chunking and embedding and uploading. You can do that. So there's a lot of flexibility. You can maybe integrate some PII reduction step in there. So personally identifiable information that is PII, you can remove that somewhere along the process. As for training LLMs, if you don't want to use an LLM that is provided by OpenAI or somebody else, you can host your own LLM somewhere, and then you have full control over what happens to that LLM, what goes to it, and you can be sure that you are not giving your data to any of the other companies.
Fantastic. Yeah, and for to make it really practical, Ollama is a great inference engine you can use, for example, where you run your LLM locally, including llama.cpp and VLLM. There's a number of things, that's a separate discussion. Thank you so much. Very thoughtful answer, and I hope that answered Sophia's question. There was a question by David Edwards that I think is on the minds of many attendees, which is unstructured can, as you mentioned, handle multiple file formats. I think a strong use case for really most SaaS businesses that came up a few years ago was just, we're creating a nicer way to work with company data that isn't Google Sheets or some type of spreadsheet solution, right? And nowadays, there's a lot of work still being done with spreadsheets. And so David's question is, how good or reliable is unstructured when working with spreadsheets? He mentioned specifically Excel spreadsheets, but I assume all spreadsheets with unpredictable formats, meaning merged cells or empty cells or cells that are just purely formatting that don't really, some Excel spreadsheets have like background colors and text colors that don't really mean much. How can one maybe even fine tune the data pulled out from these spreadsheets with unstructured?
I'm not sure what you mean exactly by fine tuning the data pulled out, but when it comes to spreadsheets, we treat them as tables, and for the tables we have very strong mechanisms for layout detection and understanding when there are merged cells, different hierarchy nested tables, all that. We have seen all kinds of nasty tables, I have to say. And so this, all kinds of weird tables are not going to be news to us. But I'm not sure what you mean by fine-tuning the data. Usually you fine-tune a model on something and maybe even cleaning the data.
Correct. Yeah. Just so you get back a bunch of data that some of it makes no sense and others are just formatting. And so by fine-tuning, I just mean like filtering out the useless stuff.
Yeah, once you have JSON, you have so many different ways to filter that out. There are many options to do that.
Excellent. Okay, let's make it really practical, because Sammy is asking for a start to finish scenario and example of taking unstructured data for a company to the finish end results, meaning a working RAG LLM application. And I think this is like prime time to show, not tell. So what if we did this? What if we showed unstructured, ingesting some data, not ingesting, that's the wrong word, but reading data and processing it and then outputting this JSON as part A. And I think we can do that with you, Maria. And then as part B, we can look at Langflow and building a RAG app with Eric. We can maybe start at the beginning with unstructured.
Absolutely. Let me just share a notebook with you. Okay, I'm going to zoom in a little bit. So, oops. There we go. I think this should be. Let me know if you want me to zoom in a bit more.
That looks great.
Okay, so in the interest of time and just to leave some time to Eric, I'm not going to run the whole notebook, but I'm going to explain how you can build a pipeline with unstructured in just a very few steps. First, you're going to need a key, the API key that you can get here, and it comes with a 14-day trial, which is capped at 1,000 pages per day. There are many ways to use unstructured API. So you can use, we have a Python SDK. You can send direct requests to the API endpoint. There's a JavaScript SDK as well, but my favorite way of using unstructured is with unstructured ingest library. So this is what we are installing here. It's a Python library. So if you're allergic to Python, I'm sorry, but I'm going to use Python here. And when you're installing unstructured ingest, you need to specify dependencies. So for your sources, destinations, embedding providers, and some types of files. So here, for example, I'm going to be Oh, I actually don't need S3 because in this example, I'm loading from a local source. So this was unnecessary. So PDF, for a PDF document, AstroDB is going to be the destination here, and Hugging Face is used for generating embeddings. Because we're going to be loading into AstroDB, you're going to have to set up your AstroDB database and collection. And you're gonna have to have your authentication credentials. Obviously, I'm not showing mine here. You're gonna need to choose which embedding model you're gonna use for the final step of transformation. And when you have embedding models, they output vectors of different dimensions. So you will need to know the dimension of the vector that your model outputs. You can usually find that information in the documentation of the model on the embedding provider's website. So if you go to Hugging Face, model card there will contain that information. If you go to OpenAI, the documentation will have that. We're going to do some imports. And then in this example, I'm loading from a local directory. So I need to know where my files are located. This is the path I'm going to use. Work directory is optional, but I like to set it because this is where I can save the caches for each and every step. So if I want to look into what happened after partitioning, after chunking, after embedding, I can go into this directory and see the results. Unstructured will save them even if you don't specify the working directory. It's just going to be a path and will be somewhat obscure and maybe not as easy to find. And so when you build a pipeline from a source to the destination, you build it from a bunch of configurations. So think of it as building a tower with Lego bricks. It's that easy. So this is all it takes. This is the whole pipeline. And let me explain what these configs are. So you specify pipeline.fromconfigs. The first one, context, and this is called a processor config. It controls general behavior, verbosity, the working direction, number of processes, the general behavior of the pipeline. Next, you specify the location of your documents. In this case, it's a local directory. So this is where we're going to be indexing the files from, downloading the files from, and where we're going to be connecting to. You can replace these 3 lines with a different connector, for example, S3, Azure Blob Storage. You can connect to SharePoint or Confluence, and there are 20 different sources that are supported. So if your source is different, if you're not doing this with local documents, that these are the configurations that you will need to replace. And for example, here, I cannot switch to a different tab. But you can find documentation for all the source connectors in unstructured docs. Once the data is ingested, next step is partitioning the files into those document elements. And this is what partitioner config controls. This is where I decide that I want to use the API and I provide my credentials. We have different strategies for partitioning the documents. You have fast strategy and high resolution strategy. Essentially, if you're processing Markdown or HTML files, you can use fast to use rule-based parsers to quickly get the results. And high-res strategy is tailored for image-based documents such as PDF, PowerPoints, images, and so on. The cool thing is that if your PDFs only contain text and nothing else, then fast strategy will also work for them, and it's going to be very, very fast. So you may be able to use it too. This block of parameters just makes PDF processing a little bit faster by setting concurrency levels and things like that. And that's it. At that step, your documents are partitioned, split into document elements. They have metadata. They are in JSON format. And normally, if you want to build a RAG application, next you have to chunk documents and you have to generate embeddings for them. So the next logical step in the pipeline is the chunking step, which is configured with the chunker config. Unstructured offers several different chunking strategies that you can use to split your documents into chunks that will fit into the context window of your embedding models and are small enough to contain precise information and enough context. But you might be thinking that, wait a second, we already split the document into elements. Why do I need to chunk them? Aren't they already chunked? And the answer to this is they're not really chunked, because you may have a very, very long paragraph, which is a single document element, which will not fit your maximum limit. So that element will need to be split into smaller elements. And then you may have a whole bunch of small elements. For example, a list will come out as a bunch of list item elements. So every list item might be quite small, and you may want to merge those elements into a bigger chunk. So this is why you still need the chunking step. And the chunking strategies control how smaller elements are merged. So by title strategy makes sure that you don't merge content from different sections. This helps with the retrieval performance down the line. But there are other strategies that take into account other aspects, like, for example, whether two elements are similar or not, whether we can merge them into one chunk based on similarity. After the documents are chunked, next step is to embed the documents. And Unstructured doesn't host embedding models, but we integrate with a number of embedding model providers. Here I'm using Hugging Face, but you can also use embedding models from OpenAI, Vertex AI, Octo AI, and a few others. Depending on your provider, you may need to provide your your key, like OpenAI key, for example. For Hugging Face, we just need to give it the name of the embedding model. And then
fantastic. So, sorry to interrupt you,
yeah.
But there's a question here from Automate Labs that they say it's the perfect time to ask, which is, can I define? So they want to know, can they define some elements themselves, like some titles, so the chunking will respect their, quote unquote, options of titles and chunking by titles, for example?
No, so this chunking strategy by title, it's the title means just a section. So we identify which document elements are section titles, and then we respect that structure and hierarchy of the document. You would have to no, I don't think there's a straightforward way to modify that.
Perfect. Thank you. Sorry to interrupt, but this was the
yeah, perfect timing. Thank you. I'm happy to answer any more questions if you have. If not, I'll just continue.
Yeah, let's continue because we also want to see the destination of this from.
Yeah, and that's the next step. So once the documents are embedded, and by the way, chunking step and embedding step are optional. So if you just want to pre-process a whole bunch of PDFs and then load them somewhere and search through them, if RAG is not your use case, you don't have to do chunking and embedding, but these are essential steps for a RAG pipeline specifically. And we can load the results into AstroDB. And for that, we need these three configs: connection config, where you set your authentication options. Upload stager will check that everything is okay with your data. And then AstroDB uploader config, this is where you specify the namespace and the collection where you want to upload the results. And that's it. So it may look intimidating at first, but this is all it takes to build a full end-to-end ETL pipeline from any of the 20 sources to the destination of your choice, with partitioning and chunking and embedding all taken care of. So takes a moment to get used to, but when you see it as a bunch of Lego bricks, it becomes much easier.
Fantastic. Thank you so much for that presentation. And it's, I don't even know Python, but that looks approachable to me, which is just a testament of how intuitive it really is. So thank you again for that. There's a question by James here in the comments who's asking, so the embedding step is really just the creation of the vector. And James, the answer is correct. There's a specialized class of machine learning models that they literally embed natural language in high dimensional space. And so they just tend to group semantic meaning words closer to each other in that space than words that are further away. But yes, they just embed words in space, and the output of those is vector embeddings, which is just a big list of numbers. Usually the models have a deterministic length. So thank you so much for that, Maria. And it's a really one question I have, and this is not in the comments, it's just me being curious, mainly because I'm kind of a novice at Python. Is there an alternate? Are there different language SDKs for unstructured? Meaning, if I wanted to do this in JavaScript, could I? Or yet?
Yes, you can. Well, not for ingest. Ingest pipelines are only in Python. You can process files one by one with a JavaScript SDK. We have a JavaScript SDK for that. And you can also send files one by one to the endpoint directly. You can just send post requests. I personally prefer the ingest pipeline because A, I like Python, and B, it's just the simplest way. You have this very easy way to build the whole pipeline by just configuring the steps, essentially. Where do you start? What do you do? And where do you land? And it's just the most user-friendly way for me to build these pipelines.
Fantastic. Great. Thank you so much. And that, everybody, is how practically you can use unstructured to go from a bunch of PDFs or Excel sheets, or soon, we were told, movies, to embeddings, to then a vector database in RAG. And again, as Maria said, if RAG is not your use case, you could just cut it off at the step where you have a bunch of JSON and process that however you want. Great. So now that the thing's uploaded into AstraDB, let's say, with that step, I'd love to invoke the Eric, my colleague, and pick it up from there and turn it into an actual end-to-end RAG application. So we extracted a bunch of data from PDFs, we followed this pipeline, and data is now in AstraDB. Eric, how might we then use this to finish our RAG application?
Yeah, so if it's okay with everyone, what I'll do is I'll show maybe two kind of I guess demo ingestible examples that are kind of, once you have your data in AstraDB, you've gone through this pipeline that Maria showed, building a RAG application off of that. And one is a code-based solution, and one is I guess what we call a low code-based solution. So let me go ahead and share.
Could we can I ask for can I express a preference for which one we do first?
Sure.
Or do you have a plan? Oh, great. If we could do the low code first, just
Sure.
because we can start at the most accessible to the most people, assuming the vast majority of people don't write a lot of code, and then we can go to the code one, provided there's enough time.
Cool. So I'm getting a message that says the screen is actively being shared. Ask the presenter to stop sharing. Is there any sharing going on?
there's no one sharing, at least that I can see. But Crowdcast maybe is having some issues. No, I don't think anyone's sharing right now. Okay, and then maybe I'll hop back on briefly and see if I can get that working. Yeah, that's okay. We appreciate that. If you guys want to talk for 30 seconds. He just left. Yes, there's a question in the audience. We can actually, this is the perfect time to take some of those. There was a question about using a domain-specific model. Is it better to use, and this is a question from Iker Riza, I hope I'm not ruining this name or mispronouncing it. Is it better to use a domain-specific AI model as an embedded, I'm assuming they mean embeddings model. I'm not sure what, I understand the question because I don't know what a domain-specific AI model is. Maria, do you have an answer to this?
Yes, I believe the question is, so when you have embedding models, you can go, especially for open source models, for example, you can go to, there's a leaderboard by Hugging Face that shows the metrics on academic benchmarks, how they perform. And there are a lot of general purpose embedding models that were trained on just text from the internet, essentially. But let's say if you're trying to use that kind of model on legal documents, there can be a lot of very specific terminology, abbreviations, and it may not necessarily do, a generic model may not necessarily do as well on those documents. So ideally, if you have an embedding model that was tailored or fine-tuned to a domain, it will perform better. Yes.
Fantastic. Thank you so much. And look, we have Eric's screen share finally. That was the perfect way to fill some downtime. Hey, Eric, yeah, let's go. How do we finish the application?
Yeah, so I want to emphasize, by the way, that a lot of what you're about to see is under very heavy development. So this is kind of like a preview of a way you can do it. It already is working end to end in a way that I think will be impressive, but there's still work to do to make it like handle more cases. With that said, what you're looking at here is what's called Langflow. If you're unfamiliar with it, think of Lang AI pipeline, a RAG pipeline, really a pretty significant number of components that they have available, and chaining the different outputs together such that you're building that pipeline almost in a graphical way. That's like a really high level way of saying what it does. But I'll show you this little pipeline. This is actually like by the standards of some of the ones that exist in Langflow, maybe on the simpler side, but I think it's how we can do this end-to-end step that that basically is what we're trying to do to build this RAG application. So we have an unstructured component. What this component is going to do is it's abstracting away that Python code, and instead what it's asking for is a file and an API key, kind of like what Maria was showing you. The components of the pipeline are kind of hidden right now, like that's an advanced feature. So it's, and obviously that can be exposed. But what happens is that file gets passed in, a number of files get passed in, and this data then gets stored into Astra DB in a vector store. So basically, we have all these, what we're looking at here is those different narrative texts. You can view the actual text of it. Unstructured is doing all the processing of this. And then what we can do is we can start to actually build a RAG pipeline. So this one is taking the data that was just outputted by unstructured and saying, hey, I want to do some kind of template transformation on that data. In this case, we're keeping it as simple as possible. All we're saying is we want to pull the text field from that data. But you can imagine you can construct a template that does all kinds of interesting things, like maybe it's tagged by some parameter of the data that got extracted, which, by the way, could be far more, I guess, like in depth in this Declaration of Independence example that I'm showing. But right now, we're just going to extract the text. So we're saying unstructured parses of the data, stores it into Astra, and we're going to build a template that's just the text that gets extracted. So you can see what we get out of that is essentially, here's the context for some queries that you might want to run. It doesn't have to just be the full text of the document. It can be a lot more interesting than that. What we can do is we can start to build the RAG application. So we're going to pipe that text in to the document that is going to underline the prompt template that we're going to create. So once again, we have all kinds of flexibility in what we build here. This is a really simple one. We're just instructing the LLM, answer the user's question based on the document provided. Here's the user's question, give me your answer. Again, we can make that much more interesting if we wanted to. That's where the power really starts to come into play. So now I can type the question in. I said, just what is this document about at a high level? So just to give it some creative freedom to answer a question. And now this prompt template, what we're going to do is we're going to pipe that in to OpenAI. Basically what we're doing is taking the question, using my OpenAI key, OpenAI key, to then generate the embeddings and compare it to what Unstructured produced in order to help answer that question. And then the last step is we get an output. So all those are chained together. Let's see what happens. We get a response from the model, and it says this document is the Declaration of Independence adopted in 1776. And you'll notice it's very specific to say at a high level, here's some of the things that it says. So the more what we did here is we started with literally just uploading a file, and we built a pipeline where you can, in this case, it's a really simple question answer prompt, but you can imagine there's so much we can do here to make it more interesting if we wanted to. And that's all done graphically by chaining together these inputs in Langflow. I didn't have to do any code. I just had to kind of gather my API keys and put them in the right place, right? So that's what we think is like, you can build a code-based solution, but you don't have to. If something like this is more friendly to you, just start building your pipeline. You basically have at your fingertips a chatbot that we just created from almost no code at all, right? Thanks to the power of both Astra and Unstructured.
That's a great point you just make. As a result of the power of Astra and Unstructured. In this Langflow diagram, what it looks like we're doing is reading a text file and then adding the entire text file to the prompt. In a true RAG application, correct me if I'm wrong, we would retrieve chunks that are ranked based on similarity to a user's query from a vector store, which we don't have here, and then feed just the highest ranked chunks. There it is. Okay, so there's the Astra. Okay, this is what I was asking. Where's the Astra DB? Where's the vector? Where's the similarity? Where's the chunking?
You're exactly right, and good for calling me out on this, because this was a little bit for sake of just making the demo a little easier. But the truth is, you're right. We wouldn't just want to pull all the text. We would have a big database. So instead, we would pipe this to Astra and then do the filter right here and do a retrieve, basically this retriever with search results that then get piped down to this. So we filter basically the inputs down to the most relevant rows from the Astra DB table.
Fantastic. Okay, and that's how. So with Unstructured, we've uploaded the chunks of, let's say, the Declaration of Independence, maybe chunked by every 1,000 characters or so, and we then ingested them into Astra, and we could search for something like liberty. And so when a user types this word, that's converted into a vector, and it's compared for what vectors in the database, what chunks are closest to this word, and we get maybe the top 5. We put them in a prompt and say, here, Mr. or Mrs. or non-binary LLM, here's the context, answer the question. Is that representative of a true RAG flow?
That's absolutely right. And while I probably can't run it end to end, I can show you for the way that you interact with Langflow to do what Tejas just said is essentially you say, okay, well, I'm outputting data here. I know what the format of that data is. I know what I can connect it to build, drag and drop a connection and say, okay, instead of going directly to the parse text from Unstructured, we're first going to ingest it and then do some search query like liberty before we pass those results to the next stage of the pipeline.
Fantastic. Great. And I hope there was the question above that. This is exactly the one we answered. I'm going to see if I can find it here in the comments. Because it was so perfect. I'm also going to highlight it here, where they asked practically what this would look like. And we just did that, right? We captured practically how you would ingest a document with Unstructured and then expose it to an LLM with Langflow. We have about 10 minutes left. Eric, you did mention you had 2 examples. Can we take a look at the other one?
Yeah, the more code-focused version, yep.
Correct.
I'm going to, again, it'll just take 10 seconds because for whatever reason, it doesn't let me reshare after someone's been sharing, including myself. So I'll be right back.
No problem. While let's do this dance again, Maria. While Eric comes back, there was a question from David Edwards, which I think is more for Langflow, which maybe I could answer, but I genuinely don't know. He's asking, can you connect two documents to the prompt? For example, RFI response and evaluation criteria. Now, unstructured would take all the documents and just put them in Astra. So Astra here would be responsible for retrieving any number of related documents and feed it to the prompt.
Yeah,
Okay,
exactly.
cool.
So let's say you can have thousands or millions of documents, and then you can have a pre-processing pipeline that ingests all of them, transforms them, stores them, and then when you retrieve in Astra and you use similarity search, you can absolutely retrieve chunks from different documents if they're relevant to the query, if they're similar to the query, I should say, because similarity search finds the similar documents. And yeah, you can have chunks from different documents added as context to your LLM in the prompt.
Perfect. Thank you so much. And Sean Duffy says Eric had to leave and come back because it's the Clark Kent to Superman shift. That's so funny.
Yeah.
Excellent. Superman, will you show us the second code-heavy variant?
Yes. Is my screen visible right now?
It is.
Awesome. Fantastic. So this notebook, I think, will be shared, by the way, and a lot of it's really what Maria covered, so I'm going to kind of skip ahead here. But what I'm doing basically is setting up in Google Colab the unstructured dependencies, and I'm parsing this paper, which some of you may be familiar with if you read about LLMs. Attention is all you need. It was kind of one of the more it's a pretty famous paper talking about some of this stuff. And what's happening is we're parsing unstructured, and I'm not yet building the full pipeline. This is just an example of parsing it. But here we get into kind of what Maria was showing, which is I build that full end-to-end pipeline, which is starting with the partition, chunking, embedding, and then storing into Astra, just like she showed. That stores into Astra. And just to give you like a little preview of what you get out of that, you can see little pieces of that paper, according to the chunking strategy, get stored as content. And of course, every row of this table has an associated vector. I think I use OpenAI embeddings here with my key. So here's the part I want to show you, given that we have that. So what I'm actually doing, this is totally outside of the realm of unstructured. Unstructured basically orchestrated this step of getting this table set up the way we want it, which is really the most important part. And now we're trying to build a RAG application. And this is a super, super simple example, of course, but it shows you how easy it is. So all I'm doing is I'm using LangChain, and I'm importing basically two packages, classes from those packages. So the AstraDB vector store, where we just basically tell it what embeddings are we using, OpenAI, this is the name of my collection, and then the parameters that are required for authentication with Astra. So really simple line to connect to seeing right here. It's just, this right here. And then all I have is with one simple call in Python. And there, by the way, there's plenty more you can do other than just a similarity search with score. But what I'm doing is I'm searching for the word German translation, because there's some paragraph that talks about a test that they use to basically test English to German translation. And I'm saying just return one result for this particular example. It shows you the similarity score. You'll notice this kind of goes back a little bit to what Maria was talking about, which is just because we're splitting documents I should say partitioning documents into particular chunks, you still have a chunking strategy after to make sure it stays within your context window for the LLM that you're using. So this is actually like a portion of a paragraph. That's why it starts out mid-sentence. But what it found was the most similar result to that query. It says more parallelizable, and then achieves 28.4 BLEU on the English to German translation test, improving over the existing best result by over 2. that should all be so that actually came right from the abstract here. So that's a portion that got pulled from that document. That's a row in AstraDB with a particular vector. And the only thing I needed to do to start building, a really simple, in this case, application is connect to that vector store that Unstructured created for us and stored the data for us, and then just print some results that come direct from LangChain. You can use LangChain, you can use Llama Index, you can use all kinds of other, even custom solutions if you so choose. As long as you already have, and the data is already there. That's why it's so simple, just one little block of code to start building some.
Excellent. That's so what we've done is we've taken the data from Unstructured, uploaded into Astra, and we've looked at how you can finish the application, both with a visual low-code tool and with an actual extension of the notebook. I want to pause here and ask both of you if you have anything extra to share, any calls to action, anything to plug, any links, any socials, and then we'll wrap up. As well, this is a call to action for the people here in the comments. There are some questions, but we're almost at time. So if you want them to have somewhere to find you and ask questions, whether it's a Discord community or Slack or maybe X, formerly known as Twitter, now's the time.
Yeah, I just want to encourage people to try the collab notebooks, and we're going to share them as well, probably in the description for the videos and in the recordings. And if you go to Unstructured Documentation, we have an example code tab there, and we have a whole bunch of different notebooks that you can try to build RAG, which is very basic and a little bit more complicated with different sources, different types of documents. So I think the best way to learn anything is to start building something. And I just hope that you have time and desire to learn and build RAG applications. And I hope that our notebooks can be helpful.
Fantastic. Eric?
Yeah, I was just going to make a quick mention. That's like spot on. And I wanted to say too that from the perspective of someone who's working at DataStax on Astra, I want to say why Unstructured, like, to me, is so invaluable and so amazing. And before I worked at DataStax, I was a statistical consultant, and I can tell you that having worked with clients big and small, it's constant that they say, "Oh, I have some data. Oh, what's that data look like? Handwritten notes, or it's scraps. It's nothing structured." And of course, everything that we do in Astra and everything we do with these RAG applications assumes we have these nice tables where we have text that's been vectorized and chunked, etc. And so having that link between data that exists in the real world and data that we need to build the RAG applications is not only like important, but like fundamental. And that's why I think this is so cool.
Absolutely. Well, listen, I know it's been quite a discussion. We covered a lot, and it's no small feat to show up live and share your screen and just walk through your content. So on behalf of everyone in the audience and myself, thank you so much for coming here and sharing all of this with everybody. Thank you for those in the comments. This discussion in the comments was so valuable. I've never had a live stream where everybody has been so engaged with so many questions. Thank you, Kevin, and Maria and Ilya and Mars and all Sean, Spyros, David, all the people who posed such great questions. Thank you, thank you, thank you.